Hello friends! An exciting video today. Very excited because this was a boatload of fun, fun in quotes, to figure out. Um, Essentially, yesterday I went to record Let's Get Serverpod live on a server. And I decided after fiddling, in my head with a few different ideas, like we're just going to go with kind of like the built-in approach, the Terraform. And that turned into about 3 hours on Twitch, struggling, running into tons of issues. Ended up kind of almost getting it, at least the architecture set up, and then the code wasn't actually running. And even if I think by that point, even if I was like, oh, like we got it working, like I was like, I need to abandon this video and redo it because I was just a bit all over the place. Essentially probably because the Serverpod teams focus so much on getting Serverpod cloud ready, they haven't really, stayed up to date with the Terraform scripts. There's stuff in Amazon that's changed and been deprecated, and yeah, it was a nightmare. What I did at the end of that stream in the last hour and a half, I'd say, is I started figuring out, you know what, let's get this on a platform as a service, a PaaS, using Docker. Because I think that's just gonna be easier for you guys than dealing with Terraform. And frankly, like I think we can do this a lot cheaper than what you would need to do to get something scalable on Amazon. And Amazon is great. I mean, the example we're going to be showing, Heroku, is built on top of Amazon, like Amazon Web Services. But it's very confusing. It's easy to pay more than you would expect, and so on and so forth. So I have a solution. And what I'm going to do in this video, rather than building and teaching you how to do it, I'm going to walk you through it so you kind of understand big picture how this is supposed to work. And then in the next video, I'm going to quickly put together just an example Serverpod project with a database and nothing crazy happening there. And we'll actually get it deployed from scratch because there's a few changes obviously made to the code and the Docker file and all that stuff to make it work. So without further ado, I'm going to walk you through how this works. I've chosen Heroku just because it's a really good dev experience. The cool thing though is I think my approach, and I'm going to test this a bit, I think it's going to work on DigitalOcean, it's going to work on Render, it's going to work on Flat.io, it's going to work on Porter, it's going to work on really any place you can do a Docker file. So let's get into it. Actually, first, let's talk about some of the challenges, and let's explain how something like Heroku or Render or all these things kind of work, because I think the context is important. This isn't like a typical EC2 or Linux VPS running in the cloud where you have complete control of the machine and can change its state and install things the way you want at any time and go in and git pull. No, they are containerized. So essentially every time you deploy, it's actually building a new instance of your app from scratch, start to finish, like installing the OS basically and doing all the things that it needs to do. And what it is it's stateless. The file system, although you can kind of use it in a temporary manner, you have to assume you can't store things there that aren't part of your code or your actual deployment pipeline because they will be erased every time you deploy. So that's one challenge to think about. Another challenge is the way environment variables work on a lot of these platforms. So they have, for instance, in your settings, you might have some config vars. These are like environment variables. And I wanted to make some changes to the way Serverpod does its configuration, not with Serverpod's code itself, but just our implementation of it, to be able to work well with things like Heroku and Render and all these various things. Meaning mostly, I'd say the biggest change is the way we want to kind of handle our database. So in Serverpod, you have sort of a config file, a passwords file that has some of your credentials in it, and then another file, a production.yaml file that has that sort of stuff. The problem with that, a couple problems. One is that passwords.yaml file is not supposed to be version controlled. So for us to actually get those settings up to our environment, we would have to decide to version control it basically, or do something funny. Basically, like it would have to be within our code base somehow. The correct approach is actually using environment variables, and we're going to read from those. Secondly, with Heroku specifically, when you spin up a database, it automatically injects this database URL for you. And periodically, this may actually change, and Heroku will stay on top of it. So we don't want to have to actually put in the database name or all these kinds of things and have to stay on top of it. We just want to use this auto thing. So we're going to actually parse this database URL, which is essentially all the data you need, but it's in a different format, it's a URI, and we want to work with that. Same with our access keys and stuff for our AWS. We want those to be sort of in here, our Serverpod secret. And ultimately, like the plan would be, we will store anything in here. This will allow us to have different environments really easily. We can have a staging environment, a production environment with completely different settings, and complete them, have them just work right out of the box. So that's like one of the challenges. Another big challenge, specifically with, although I've got tons of different projects in the past running on Heroku, one big challenge here is Serverpod is actually kind of three applications running, right? You have your API, you have your web server for like the web server, we're not really using in our project yet, but it is, part of the puzzle. And then you also have your insight server. And those all run on different ports. But with something like Heroku, you can't just point different domains to your application to basically be like, okay, this is the this is the subdomain for insights, this is the subdomain for this, and have them all point to the same place and route it. So we had to do something a little bit interesting, and I'm pretty proud of how we made that work, and you'll see that in a bit too. Yeah, that's at least. I mean, I'm gonna probably stumble on a couple other challenges as we get into this, but I'm gonna show you how we put this together. And again, I'm not gonna actually do the code right now or the implementation. We're gonna do that in the next video, so you can actually see the steps that you would need to do if you want to bring this to a platform like this. But I'm gonna give you that big picture view right now. So first of all, we are not using, if you've used Heroku before, you're probably familiar with things like build packs. We're not using a build pack, so they have different build packs for things like Python and Go and Scala and Clojure and all these kinds of things that just are like kind of like a template for like, these are the things that need to be installed. This is what the build script should be. These are those kinds of things. But there's nothing here for Serverpod. There's not even one for Dart. So we kind of have to go a different approach where we're actually using a containerized application. You'll see here. The framework is container, and we're actually using a Docker file to essentially tell our instance, hey, this is what you need to install, this is what you need to build, this is what you need to expose, this is what you need to run, so on and so forth. One more challenge, just while I'm thinking about it, that Heroku has is, although you're going to be hitting the app, and I have it open here, this is just the API route, which tells you, the time, so we're working. Although it's HTTPS and it is port 443, because that's what HTTPS uses, we, under the hood, there's actually some port forwarding that is happening. So the 443 actually goes to something in Heroku, points to, essentially a load balancer. And that load balancer then points to our apps. And it actually uses a different port. And it's a randomly assigned port at the time of run, or build at least. Somewhere along the way, there's a random assigned port. So we actually have to consider that it's not going to be running on port 443. It's actually going to be running on this random port. So that's just one more challenge that I had that we have a solution for. So let's walk through it. I have the project open here. So this is all within the, all the files we're going to be looking are within our OpenMic server. Except for the very first one. We actually have a Heroku.yaml, and if you're going to DigitalOcean or something, we're going to find out, I'm going to play around with those in the future and update people in another video on the small changes. But this is the only part that's actually really Heroku specific. And all it's really doing is saying, hey, for the build command, we're going to use Docker, and we're building a web instance, which is different than like a worker instance. Basically, a web instance exposes, to the outside world network requests, as opposed to a worker, which can just kind of do its thing. But we're saying we're going to use web, and this is what we want to run. We want to go into our OpenMic server folder, so the Serverpod server folder, and then find that Docker file. Okay, so that's all we really have to do. The other thing you have to do on Heroku is actually just configure it as a containerized application, which we'll do in the next video. We'll show you how to do that. But that's all we really have to do to tell Heroku, hey, like, this is how you handle this. And then our code, as far as I am concerned, without full testing, should be agnostic to any platform that supports containerized, Docker-based deployments. Okay, so we have that in place. Cool. Let's look at our Docker file. So this obviously was a bit of a challenge to really figure out. I started with the Serverpod Docker file, but made quite a few changes, relying on things that I searched for, a little bit of ChatGPT, and some articles out there. So the very first thing is, although this was actually a change, I picked the most recent or closest to my local version of Dart. So if I run Dart version, we're actually on 3.5.3, but there isn't, at least at the time of me making this yesterday, there wasn't a 3.5.3 version of of a Docker container. So we're just using 3.5.2, just a minor behind. That should be fine. But I think it's a good practice to try and keep your version in the cloud the same or as close to the same as your version locally, because then you don't run into weird issues that you're only experiencing in one environment. And that's just a good plan with any software development. And that's what's great about Docker too. You can have that kind of stuff. So we're importing Dart as build. So we're just creating an alias that like this container or this template or engine or whatever you want to call it, we're going to reference as build down here. Then what we want to do is set our working directory on our server to /app, and then we're going to copy everything. So we're basically copying everything, and it's just, we're within the server folder right now. So we can ignore the Flutter folder, we can ignore the client, our resources, whatever. We're just really working inside here right now in terms of Docker. It doesn't care about anything outside of this. And then what we do is we want to get our, Dart pub get, and then we actually run the Dart compile. So we compile it to an actual binary, which is kind of nice. And that's just something that Dart lets you do. So cool, we're going to compile it. Then we're going to load Alpine latest, and this is just a Linux starter pack, I guess, in Docker land. I'm not by any means an expert in Docker. People in the comments want to correct me what that actually is, but this is kind of like getting us things that so that we can work, with our Linux environment. Then there's a few things we need to install. We need to install nginx. We need to install bash, and really we only need bash so that we can kind of run some commands, and if we wanted to actually log into our server, our instance of a server, to actually just play around in there to see did everything go, I need to get bash. I also have curl. I don't know if this is actually needed. Maybe I'll try doing a test without it. It was just part of my debugging process again. And then we need something called supervisor, which we'll get into very soon. Then we're setting some environments here. Some environment variables, essentially, the run mode, the server ID, and the logging, normal, and role serverless. So the first three, this was just actually in the standard Serverpod Docker file, just saying what mode you're using and that kind of stuff. Then role, that's something I actually had to change. It was monolith, which has a monolith configuration, has state, meaning it's expecting like it has a normal file system and it can change things and whatever. We really just want serverless because this is a containerized application. And the idea is with Heroku and all these things, we can actually spin up 100 instances of this and have them all load balanced if our app got really popular, although I don't think we'd ever need 100. That'd be a pretty killer app. And the idea is they should all work independently from each other and not have to worry about, oh, did this file get downloaded here? Like they all just need to work the same. And that's what's kind of cool about, serverless sort of stuff. And I think serverless is a weird word because it's still a server, guys. I don't know why that, term sort of took off. It's just a different way of doing things than, 5 years ago, I guess. All right, then what we do is we, from our build, so we're using now this alias, we're copying some stuff. So we're copying the runtime, we're copying the app bin server. So that thing that we compiled here, we're going to put it right into a file called server at the root. We're going to copy our config, we're going to copy our web, and this was something we had to add here. These were already part of the Docker file. We want to add the migrations in because we want to make sure we run those migrations if there's a change. All right, so that's pretty cool. Next thing. And this is where we had to add some pretty crazy stuff. So we're using something called supervisor. And supervisor allows you to essentially run and manage and respawn and restart if there's problems, different processes on your server. Generally in a normal Docker file for like a web service for say like a Flask app, you only really are running one main process. It's just like, starting the Flask app and listening and just staying there and being like, I'm listening. But we actually have to do a couple different things. And what I ran into is if I tried to do this one thing and then if I tried to start the Dart server, right, and then do something else after, it would never happen because the Dart server is just hanging there and waiting. It's in the way. So I landed on supervisor after trying a couple things, and I've used supervisor a lot in the past. It's totally great. So we're copying this configuration file from our code base, which I'm going to show you in a minute, right into where it's expected to be. And remember, we installed supervisor, so there's going to be these folders and stuff already set up. Yeah, supervisor D. So what we have is we have the main program, which supervisor D is just like the daemon that is kind of observing these things. And there's two things we want to run. One is nginx, and we'll get into that in a bit of why we need to use that. And then our actual Dart server. So nginx, we start by basically running nginx -g, and then we run daemon off. Although now that we're using supervisor, I don't even know if we need this. This was just something I was playing with. Maybe I'll test also getting rid of that part because it will run sort of in its own world now. And then we have auto start and auto restart. So if something goes wrong, it'll just restart. When this system starts up, it's going to start, which, that's great. Then we have our Dart server, which we're going to go into our root directory, and that's where we copy to. We're going to run server. We're going to actually apply the migrations. So just make sure that, any migrations, if any, will run when this thing goes up. Now, I do have a plan to maybe alter this to make this part of like the part of in the Heroku thing, you can actually have a release command. However, I am trying to make this agnostic not to Heroku, and maybe it's just better to keep it in here because it's totally safe. You can run apply migrations, and it'll just be like, oh, there isn't anything to do. Cool, moving on. We want to set the mode to production. We're going to setting server ID to default, and we're going to set login to normal, and the role will be serverless. And now that I'm reading this through, I realize I no longer actually need any of these anymore. I'm going to just get rid of these because they used to be here when I was making this, but now they're in this own file, and we have them hard-coded because this is just for production. And same kind of thing. So we have that. Cool. So we basically copy that over. Then, and this is one of probably the biggest challenges, is how do we deal with the fact that we need to run multiple things? Serverpod expects you, based on the Terraform scripts and all this kind of stuff, it actually expects it's going to set up multiple subdomains. So you'd have insights, you'd have API, and you'd have, I think, just the root, www or whatever that would point to web. And there's some port forwarding that goes on to get those things to all work. But we don't really have that liberty of doing this. In Heroku, you can't just point, I guess you can point multiple domains, but we'd have to do some like tricky stuff to be like, okay, if it's this domain, do this, if it's this domain. So the way we are actually handling this is we have an nginx.conf that gets copied over. And here we go. I'm spawning it with 4 worker processes. That's something you could tweak depending on how many things you have. We're just saying like the error log is going to be standard error, and we're just setting a PID, which is like the process ID to be pointing to this right here, this like socket basically. Worker connections 1024. That's just like a default. Probably don't even need this. I think it'll just fall back to that. Then here's where sort of the magic happens. So we're creating 3 different essentially services, and these are corresponding with Serverpod's different default ports. We could in theory make this whatever we wanted, as long as we updated it in the Serverpod code and also in our Docker file to expose these ports. But yeah, so we're saying the API service is going to run on 8080, all pointing to localhost. We're going to run the insight service on 8081 and 8082 for the web service. And again, that is just kind of the Serverpod defaults. And even when you're running locally, that's what you're going to kind of get. All right. Then here's part of the magic, and we'll come back to this. We're listening on this thing called insert port. So this is essentially a variable that's going to be replaced, and we'll see the magic of that in a little bit. So we want to listen on that, and that's the magic port that essentially Heroku is sort of using from the 443. They're forwarding it to a different port that's randomly assigned when you build. And again, it will change every time. And if you have multiple instances running, they might all actually be different ports, and that's totally fine. So we have that there. Then this is the real magic. So I don't know if you probably didn't pay attention, but we're not running it on subdomains. We're actually running /API. If we just go to /root, we actually get the web service, and we can also go to /insights. And we'll get the insights. Now, insights and API basically look the same. They're just giving you like a sort of status thing, but it is working. So what we say is okay, if someone's coming to the location API with a slash at the start and the slash at the end or whatever, I'll skip this one. We'll come back to this. But we're proxy passing to our API service. Cool. And then we're making sure we pass the headers through and all that kind of stuff, basic nginx stuff. And the same thing for insights. We want to go to the insights service, and just a / we're actually going to point to the web service. Cool, great. Now, something else we had to do is we need to do a rewrite on the URLs, because Serverpod under the hood is not expecting there to be something that's like /API or /insights. It's expecting it to run right on the root of the .com or .ca or whatever it is. So we need to do for these two, we need to actually rewrite the URLs so that this gets removed from the context of the service itself. So it's nginx is basically going, yeah, I know you have that URL, but I'm taking that path away when I pass it off, and everything's good. So yeah, that was a bit of finessing to make that work. So then we have nginx going. Going back here, we are then running the start command, okay? This we, in theory, could just put the start command down in here, but I think it's just cleaner to have this. So we have a start.sh, and what this is doing is two things. We'll come back to this one, but the main thing it's doing is it's running supervisor and pointing it to that supervisor.conf file, which is this right here, which basically just starts these different processes. Cool. Now what's this right here? Well, we're using something called sed. Sed is just like a built-in Linux command for replacing text in a file. And what we actually want to do is it's going to search for that insert port magic word right there. So again, if we look here, we actually see insert port, cool. And what it's going to do is it's actually going to take the environment variable port, which is something that Heroku and you know these things kind of are going to expose to us, and put it in here. And it's going to replace it in this particular file. So it's looking in this file, and it's going to replace that before actually starting. And that's how we get that magic of the port moving forward. Cool. So yeah, that gets us going, and it runs. Now, I did mention at the start, there's a little bit we needed to change to make things work, specifically for like environment variables, because we don't want to be, you know, version controlling our passwords text, And I found out, luckily, in Serverpod, instead of relying on those files, you can actually just pass in configuration. So you can actually pass a config in our main Serverpod thing. This is just the server.dart. And we can pass configuration for our API server, our web server, our insight server, the database, and our server secret, which are all things we want to get from our environment. So how do we do that? Well, I have created something, and it's right in the root of the lib folder called environment settings. And this is kind of similar to what we did on the Flutter side with using something like .env to get settings. And we are using .env here. So what this allows us to do is have a local environment that's different from our production environment, and in fact, many different environments if you're working with another dev. So what we have is for local use, because we're not going to have these environment variables unless we manually set them each time, we're going to have a .env folder right in the root of our server folder. And this is just where we kind of put our database URL. Note it's in this sort of format now instead of being broken into 5 or 6 settings. There's also a setting to say, hey, use SSL, and I'm doing it kind of in a negative way, and it'll make sense in a minute why I'm doing that. And then our Serverpod service secret. So these are just our local settings. And what we basically do when we instantiate this, which you'll see we go like this, we just right at the start of the run, we get our env settings. It's going to try and read, it's going to look for a .env file. If it doesn't find it, it's fine. But we're using include platform environment. And what that will use, it will actually use the environment variables in your system, which of course are things that we have access to, such as this stuff here in Heroku or in Render or wherever you're hosting. We can get that. And there's a few things that we're just going to say, hey, if you don't have these set, like the application is not even going to start. So for instance, if env database URL is equal to null, and that's whether it could be coming from the .env file that's not going to be on our server, but it will be local, or coming from the environment variable itself, we're just going to throw an exception and tell them, hey, you need to have this set. Similar, if you don't have the Serverpod secret, we need that. Then what we do based on that database URL, we actually just parse it. So we get the URI by doing a URI.parse on that. And the parsing allows us to get the host, get the port. We're able to get the user by taking, if you look closely at this, the way it works is this is considered the user info in a URI. It's basically everything before the @ sign, but after the // But we actually need to split it on here so that we can get the username and the password. So we get that. We split it. We get the first, split it, get the second. That could probably be done slightly more optimized, but it doesn't really matter. And then we get the name by just getting the path segments.first. So that's basically path segments are anything after this /. So this is the name of the database, and we have that. Then generally, at least in production and in Heroku and all these kinds of things, RDS, whatever you're using, you will want SSL on your database. But for local development, we don't. So what I've done is there's an environment setting. This is basically an optional setting, database no SSL. If we set that to true specifically, it's going to flag that. And we're going to say, hey, don't use SSL. Otherwise, if that's not set, which it isn't in Heroku, it will use it'll just set it to true. True is kind of the default. And what we do is we override the negative part of it. I just thought that was better than making it a field that you have to put in, like database SSL, true. Like to me, that is generally going to be, the approach. So we just kind of override it locally or in any environment where for some reason you don't have a secure Postgres. So yeah, we do all that, and then we actually just set some things. So we're setting our service secret just simply like this. These are just late strings. We're setting our database config, and this database config is just built into Serverpod. It's essentially what this field is expecting, database config. So we're just passing that stuff through, and everything's good. So now basically, I don't know if I have any changes. I think I have. Oh, I do have some changes. Oh, right, because so you'll see some Terraform stuff here. I actually, prior to this video, started doing a Terraform destroy because of the work I did yesterday. I was like, I don't want to pay for these Amazon things that got spawned up. So I have a slight different change. So I'll commit that just so I can kind of show you. Let's just do, there was a minor Docker removed non-necessary env vars. And we can actually test this right now. So again, I'm going to show actually do this in the next video, how we actually go through and do this process. But basically, I have this just set up just for testing purposes. I set it up as just manual deploys. You can set up automatic deploys so that every time main gets merged, it essentially does a deploy or tries to deploy. I'm just having it set up manually so I can do it when I want. So I just click deploy branch, and we'll actually see this coming through and doing stuff. So let's see if we broke anything in those small changes that we made. So we can see the build command running right now. So this is just getting the Docker file started and pulling some stuff on it. Pull complete, cool. I can actually click this to see the build log bigger, which is probably better for you guys watching. Make it real big. And it's basically running the commands like that we saw in the Docker file. Cool, it's doing the stuff. It's running the Dart pub get. So we see, just like you'd expect, when you run Dart pub get locally. Then we're compiling it. And so on and so forth. And let's see if this goes through. I'd be surprised if we didn't. I didn't make any drastic changes, but it's always good to test. There we go. We're copying stuff. We're running the start command, and then it's actually pushing now. It's done like the build and everything, and it's pushing essentially the application state of like what happens after a build right to Heroku and actually going to launch our application. If we actually go to just the activity feed in general, which will open a new tab in case you want to come back here, we'll actually see in Heroku, oh, that was quick, it's deployed. All right, so I guess it's done. And there we go. If we go here now, let's just make sure we didn't break anything. So /API hits this, and just the root gets us our thing. So we have it. We're running. So yeah, in the next video, we are going to actually go through this process on a fresh project, like I mentioned, and so you can set this up yourself. But I definitely thought it was a good value just to kind of show my thought process and what I came up with after a lot of struggling. If you're really interested in how the Terraform stuff went, find me on Twitch. The video would have been on October 16th, my stream, and if you watched through that, it was a few hours of super fun. And we had a good time on the stream trying to figure it out. So yeah, thanks for hanging out. I look forward to helping you guys get this online, and see you in the next one.